Okay, few announcements, and then we'll jump into our lesson today. So number one, Unit 4, retake corrections, all that jazz. The Unit 4 free response retake has been there, and so it is still going to be due on Tuesday of next week. Okay, so if you're wanting to retake the Unit 4 test, put that on your to-do list this weekend. Okay? For the multiple choice, because of my delay of some issues, I'm going to extend and leave that open. It should be open right after school today, is when it should open up for you. That will stay open all through next Saturday, since I took longer to get it there than I wanted to, for the multiple choice retake. Okay? But once again, that's kind of where those are at. So sorry for the delay for those that were. I know some of you have been ready to go. So any questions on dates or things like that?
So when let me submit the FR2 corrections on Canvas? So I emailed them to you. Was that what we're supposed to do? I was confused.
No, but it's fine if you did, like as long as I get them. I'll look though and see, because that's good to know, so not everyone.
It wouldn't let me upload.
It wouldn't have an upload link?
Yeah.
Okay, I'll check it. Maybe I have to click a little box, so I probably shouldn't click that box. So good to know though, because then that way everyone else doesn't have to email to me. But you don't need to resubmit them, so.
Did you post multiple choice for this?
So that one's gonna open up today. So today after school it should open up, so. Yeah, I
So at the beginning of the year, you talked about how there's like 2 different ways you could do it. One way that you could do the whole test, the
Yes.
other way you could just do the questions you got wrong. Are you still letting us do the whole test and then
Yep.
do as many as you want?
Yep.
So is there only one on Canvas right now, or is there 2?
For what, multiple choice?
The
Or
free
free
response.
There's only one, but so what you need to do is if you want the opportunity to retake your retake, after you submit it through Canvas, send me a message, because then I'll know to grade yours, because otherwise I kind of wait to grade them. But then I'll grade yours, and then if you don't pass it off, then I'll just send you the next retake.
Okay.
Does that make sense?
Yep.
So yeah, no, that still is available. If you want to retake the whole test, you have the opportunity to retake your retakes. So, but yeah, good question, Isaac. Any other questions about those things? Okay, before we jump into our lesson today, I have some important business. I'm putting together a 4x400 meter team, and I need 4 runners. Who wants to join my team? No.
Running is painful.
Okay, Carly can't do this race by herself. Come on.
I don't run.
Wait.
Is that right, Carly?
Me, Bryce.
Okay, Zach,
I mean, I think I could.
Bryce, come on, I need one more person for our relay. Isaac, okay.
Dang it. I tried to volunteer.
Okay, so for those that aren't familiar with running and track, okay, a 4x400 means that each of these people are going to run 400 meters. Okay, so it adds up to a mile. So 400 is just one time around the track. Okay? So, Carly, how fast are you going to run your 400?
65 seconds.
Alright, she's going to run hers in 65 seconds. Pretty speed. Zach, how fast are you going to run yours?
I don't know. Pass.
Fast.
Under 50 seconds.
Wow.
32. Break the world record while you're not. No big deal.
He's going to run a 48.
That's
Yeah.
That's speed right there.
He's going to break the Skyrim school records.
I'm gonna sprint it.
Actually, that might not break it.
I think, what's the score? I forgot his name, but
Josh, I think
Josh
he went
Taylor
under.
had 37 something.
Did he go 47?
Or yeah, sorry, not 47.
Yeah.
He might have gone
I think
47.
he had like mid 47.
But still really respectable, Zach. So, okay, Bryce, how fast are you going to run?
53.
50. Okay, now I'm going to pick on Isaac, because I know Isaac and he'll forgive me, hopefully. Isaac's going to take 10 minutes.
Ooh.
Even I can run fast.
Come on, dude.
No,
You're
it's
that
seriously-
close to gold, and then you.
For my swimming standpoint, it's
So,
just-
if this, everybody, this is our 4x400. It's a pretty solid team. Sort of. With this setup, let's say Carly has a really good day, and instead of a 65, she runs a 62.
That's a really good day.
PR.
Does that really matter, though, in the big picture?
No.
Why not?
Because
Because
Isaac
Isaac-
is just so slow.
Because we don't know what happened to Isaac, but he got lost on the track somehow, right?
So, go ahead.
The point here is that the slow step is the one that really is going to influence how well this team does, right? All the other ones could drop some time, but in the end, it still is dependent upon this 10-minute 400-meter. I can't even walk that slow. I
Yeah,
didn't know how
I
you would do
know,
that. One lap on the track in 10 minutes. But
That's like you take a rest out of
yeah, that's true.
No, he's doing it.
Maybe he's walking on his hand.
Maybe he's like inching across the floor, like he like stretches.
Oh, like
himself up
literally
and
on his
pushes.
belly. Like.
Yes.
So today we're going to look more at mechanisms, this idea of how things can happen in multiple steps. When we look in terms of the rate of how fast a reaction can happen, the rate of the reaction is dependent upon the slow step. Okay? It doesn't matter. What if I put Isaac first? Would that help me?
No.
Not really.
Not really, right? Still gonna be in the end about the same. So it doesn't matter where a slow step is in a mechanism, that is the step we are going to focus on. Okay, so in our problems we're doing today, always focus your attention on the slowest because we want to help them the most. Or in a sense, they're the one that determines how quickly a reaction can proceed, okay?
Or we could just, pick them up.
Yeah, that's a better idea.
Well, we'll talk about how we
Sorry,
can bring in a
Isaac.
catalyst
You're
and they
out.
can like pick up Isaac. You know, and
And
help
then,
him go
or,
faster.
Yeah.
See, that guy's ripped.
I volunteer Taylor.
Taylor will take that job. Okay, so as we're looking at mechanisms, okay, what we have is what is known as the rate determining step. The rate determining step is that slow step because it determines the rate of the overall reaction. When we look at our reaction energy profiles, our little roller coaster graphs here, okay, keep in mind that each hill of the roller coaster corresponds to a different step. So this would be classified as a two-step mechanism, right, where this is the activation energy of step 1, this is the activation energy of step 2. Obviously, since the activation energy of step 2 is a lot higher than step 1, this would be what is known as our rate determining step. What happens is you kind of get this weird thing of where the reactions are, once you think of it like a roller coaster, okay? If the molecules have enough energy to get here, then they kind of get stuck. And they kind of do this thing until finally they have enough energy to get over the next
I
activation.
get dizzy.
That'd be quite the roller coaster ride, huh? If that was a real thing. That would be actually quite interesting. But anyways, so with this idea, that's why we focus our attention on that slow step. Because once that's through, pretty much the race is over, right? I mean, even if we put Isaac first, once he does his 10 minutes, the other ones are going pretty darn quick. So the race pretty much ends as soon as the slow step happens, okay? So when we look at, few notes on this, when we are given a mechanism, and I forgot it up here, but it's on your paper, the mechanism will always tell you which step is slow and which step is fast, okay? Because that can only be determined experimentally, okay? You can't look at a person and say how fast they are,
Well, to an extent.
to an extent, right?
Obviously, Taylor's running like 12, 13-hour miles. Look at
Okay.
his legs, I mean.
So we can't
Poor
look at
guy.
a step and assume how quickly that collision can occur. So just be aware this will always be told to you in the problem. Okay? Now, what we're going to look at here is what happens when that slow step is happening first. Okay? So first thing, let's write for a smiley face. Give me the overall reaction. Ready, set, go.
Oh.
Give me the overall reaction. Give me a pencil drop when you're done.
Because like, I've tried like maybe canceling
Good question. It
these
should be
throughout
balanced.
seniors.
Yeah, that's actually a good catch, is if it's not balanced, then,
No, it's,
Those-
it's so annoying, because like my brother's like this freaking business, it's like 6 AP classes, and
Oh, I guess maybe it takes
and I'm over here.
I don't know.
oh, there you go.
That means I'm smart.
Okay, if you have,
Oh, they're calling me lazy.
No, I'm saying assignments are heavy.
I know he takes 6 of them.
So he's just good at doing assignments. Like that's what that
That's the first thing I've gotten right all day.
She's good at what she's saying is
Yeah, exactly. I know.
I wish I had my binder so I could.
Get out.
doesn't mean you're dumb.
Yes, yes.
Oh, you're complimenting me.
Yes.
Oh my gosh. I'm just too dense to realize it.
Yeah.
Thank you.
Okay, if you have this, give yourself a smiley face.
You're not wrong.
Wait,
I'm
wait,
just
wait,
gonna
wait.
say,
N2?
And can I have a redemption point on my quiz, because now I did it right?
Yeah, same.
No, maybe not a smart face.
That doesn't make me. That's okay, I appreciate it.
You're welcome. Okay, now here's the goal, everyone. We want to know what is the overall rate law for the reaction, right? Like how quickly or what influences how quickly the reaction can proceed. Now, when things are written in steps, we can write rate laws for each step, just like we did on the quiz. So the rate for step 1, or the rate law for step 1 would be rate equals little k, NO2 to the second order. The rate law for the second step would be rate
Wait,
equals k, NO3 CO. Yeah, got it.
I'm sure you already said it, but like, how do you know if it's squared or not without like the numbers, like the table?
Good question.
realized are?
So when it's a step, it's a single collision reaction, which means the balanced equation is
Okay.
the rate law. So since there's two NO2s, that's why it was second order.
Oh, and then if there's like a coefficient of a 2 before one of them, that would also make it a 2?
Yes.
Okay.
But building off that question, when something is not a single step elementary process,
oh, that one.
you can't write the rate law by just looking at this. So I'm gonna do something that you shouldn't do. Okay, so it would be wrong to just go like this and say, oh, well, the rate of the overall is K NO2 CO. Okay, we can't do this because it's an overall process. Everyone see the difference? Because Gavin brings up a great point that you can only write rate laws based off experimental data. Now the data here is hidden in the fact that we know it's a single collision process. Okay? So this is our goal though. We want to know what is the overall rate for this reaction. Now once again, the focus is on the slow step. Okay? Because once the slow step controls really how quickly this can proceed. Now in this case, because the slow step is first, okay, our reaction graph would maybe look something like this, where we got a really big hill and a really small hill. Okay. If this is a roller coaster, okay, once the roller coaster gets up to here,
Does it gain speed while dropping?
Yeah, like, is it
Well, like,
momentum?
yeah,
like,
does
it
it,
gets
with
fast
the,
and fast?
with the, like, would it gain energy when it went down the roller coaster end?
What's this?
it's releasing energy.
So would that make it, never mind.
Wait, what's the speed like if I drop terminal velocity? Is there like a terminal velocity for this kind of stuff when it's falling, like maximum?
I don't think they're falling, I think it's a
Yeah, they're not really falling, it's just showing the change in energy, right?
Confused.
But if we visualize it like a roller coaster, once the roller coaster gets to here, does it need any more energy to get to there?
No.
It would just flow. So because the slow step is first, the slow step is the overall rate law.
So like the second rate law is just, doesn't even matter.
Pretty much. in terms of the overall.
Fascinating.
Yep.
Way. But then if the slow step is second.
There you go, you're getting to where we gotta get this.
Oh no.
When they calculate any other part.
Oh, you're mean to me, Taylor.
Okay,
You, I mean
when the
chemistry.
slow step is first, it is the overall rate law. Yeah, Zach,
How do you figure out which one is the slow step and the fast step?
they'll always
They'll
tell it
always
to
tell
you.
you.
Yeah, good question though, because it has to be, experimentally is how it's determined. Like scientists go into the lab and run these things, so. Evan,
So what would the overall rate law be if the fast one was first?
hold that
Okay.
for 2 minutes, and then we'll get to that. Great question though. Got it.
Could they not tell you which one's slow or fast if they give you a graph like that and say step one, step two,
Ooh.
and they have a
Now
graph?
you're thinking like AP people, yes.
Your mom is an AP person.
Yeah.
You just say my mom is an AP
No.
person? I'm so
But yeah,
confused.
totally, I get, they give you some sort of information, but they can totally do it that way. Yeah, good point. Let's do this practice problem and then I'll say what I was gonna say in a second. So, try this practice problem with your table buddy for a smiley face. Ready, set, go.
Okay, so,
There's not catalyst, right?
no, because,
So the first one is rate equals to A, unless it's separate. Okay, then we have rate,
Yeah, but it has to make some.
okay, so let's do the overall.
Am I doing this?
So what's changing? So,
Right, yeah, I thought I figured it out.
the overall rate one.
No, no, no.
is the rate equals
Put your pencil down when you're done.
Why are you laughing at me? You don't get this.
The overall rate is just.
wait, oh yeah.
Stumbling on my brain right now.
Okay, we need to find.
Brain stumble, I like that.
Ah,
Having a brain stumble.
So it would be,
something a
so
British person.
the
That does sound like someone Sherlock would use.
Oh, yeah.
equals to
Wait.
L2.
Man.
Yeah,
This is out.
yeah, that makes
I was
sense.
like, hey.
Or do you think it's two
No, I
and
don't.
L?
Nope.
I don't think it's 2 unknown because that would make sense, because we have to have one single one.
Oh, wait a second.
Oh, wait.
We're only getting to the overall.
I think
Yeah,
we should
it's 2
retake the
unknown
quiz at
because,
the end of the
yeah,
class.
yeah,
That's a good idea.
And then you take your better
yeah,
score.
we'd have extra.
Cause I will do
overall.
so much better.
So 2
Yeah, no,
unknown
me too. I
plus
just missed like one spot.
Like I come up with a new quiz,
That would
Yeah.
be great.
but
too.
similar.
Yeah.
Yes.
Yes.
I feel like I could.
Or
redeem
just the
myself.
same quiz, we're good at the same quiz.
Cause honestly, I have already forgotten the question.
You should know by this point, Taylor, how I feel about giving you the same problems more than once, right?
Oh.
But you do that on the test.
No,
Oh,
they
Quizzes we
switch.
take and then.
Oh, that's true, there is some
Oh,
repetition,
look at
that's
that.
true, that's true.
Dang it, Taylor, you outsmarted me
Outsmarted me again.
You've outsmarted me again.
Okay, everyone ready to check it?
Yeah.
Okay, so the question says, a possible mechanism for the overall reaction above is the following. Okay, what is the rate law that best agrees with this possible mechanism? Okay, so what we're looking for is we want to know what is the overall rate law that matches the data or the equations they're giving us. So, first thing is we look at where's the slow and where's the fast. In this case, the slow step is first, which means whatever the rate law is for the slow step is the final answer.
Oh, got it.
We should have rate equals K.
NO squared. Yo! Let's go!
Have a smiley face if you got that. Any
I
questions?
was trying to figure out the catalyst in trap like that, and I was so confused.
Yeah.
Did I
I
just
know, I
do-
realized you didn't even need to do that.
Yeah.
I was like, I'm.
Wait, so if you were like supposed to figure out the catalyst and intermediate for this one,
Yeah,
could you do that real quick?
sure. So intermediates, I look for things that are made and then used. They already gave you the overall, so you could also look at what's in here but not in there.
Oh, I didn't even see that. I really do.
Or you can write the overall too.
Whatever.
So, N2O2 would be an intermediate,
Well, now I know that I can do
used,
overall.
and there's no catalyst.
Oh,
Uh-huh.
wait.
See why?
Yeah, but don't you like cross out the, oh wait, no, I used my brain. There it is. Okay.
Got it?
Go.
I just saw the 2 in the end and then the N in the subscript. I was looking.
Oh, gotcha.
I was like, wait a second.
The little tubers up and down.
Yeah, I got
Okay,
it now.
now what I want to point out here, everyone, before we answer Evan's question, okay, this is my overall reaction. Okay, O2 is a reactant. It doesn't show up in my rate law, so what does that mean about O2?
Spectator?
Uh,
Spectator?
or no.
It is in the fast step.
It means that it doesn't require.
The
It's
spectator.
unnecessary.
It's not, it is necessary because it's a
It's
reactant.
not limited.
It's a not linear.
It's not dependent, at least speed-wise, upon how much you add. It's zero order, right? You can pour as much O2 in this reaction as you want, and it's not going to make the reaction go any faster. The reaction is only dependent upon how much NO you put in there,
That's true.
okay? Okay, let's talk about now when the slow step is in the first one.
Oh my
Okay. Now, once again, it's still about the slow step. Once again, we don't care where we put Isaac, we care about him. Okay? So when
You
the
are
slow
love.
step,
No, we said that at the same time.
Really?
when the slow step is in first, it's still our focus though of what's happening, but there's just a problem that often happens when it's not first. So let's write the rate laws for each of these steps just like before, okay? Want some smiley faces?
Yes.
Okay, do it yourself. Okay, so write me rate law for step 1 and the rate law for step 2.
Oh my gosh, the arrow goes both ways. That's
Isaac, does my camera reach all the way over here?
Yes.
Yeah, okay, thank you. Set your pencil down when you're done. So write the rate law for step 1 and the rate law for step 2. Compare with your table buddy. Different C word.
What'd you get?
No, you did.
I'm just.
What does that mean? Oh, okay. Awkward.
K and
Have you seen that chart?
If you haven't read this, okay, wait.
Yep. Oh wait, I forgot that.
If you think about it,
No.
She's a dragon from Harry Potter.
You're right.
Oh.
That's amazing. No hurt.
In the two. Just think
Okay, you gotta
about it.
do
So
it.
technically it'd be no bird 2,
Yeah, but
they find out it's a girl and call it no bird 2.
so that's closer.
Okay, check your answers with mine.
I know, that's how I feel whenever I see K2SO, and then I just think of row 1.
I never even thought of
Gonna
it.
be a smiley face.
And then I just can't think for the rest of the lesson.
Okay, smiley face for each.
Yeah, you know that one too.
Okay, now, before we would have just said, oh, here's our overall rate law, because it's the rate law of the slow step. The problem is this, okay? NOBr2 is an intermediate in this reaction. You can't have intermediates in a rate law, in an overall rate law, I should say.
It's okay, it's okay. You can stop making weird frog noises. Oh. I'm like a frog. So awkward.
Okay? You can't have an intermediate in an overall rate law.
So is that technically wrong? Is
So
that a
it's-
wrong rate law? I'd
It's
like a.
just not a complete, it's not the true overall yet.
Okay.
We're gonna build from it now.
But it's the correct for that step.
It is, yes, for the step it's fine.
Okay.
But here's the problem with an overall rate law having an intermediate. Intermediates are something that are made and then used. So they can detect them, right? They know they are existing, but brackets mean concentration, they mean molarity. We can't control the molarity of that intermediate, nor can that, like we don't change it because it's made and then used. We don't dump it in. So what we need to do here is we need to take that rate law, but then substitute out the intermediate for something that it is equivalent to. Okay? If you want to flip your page, the next page at the top has the same exact reaction, but with a little bit more space to work.
That's
Okay.
nice. Wait, you made these little packets?
Yeah.
Oh, that's sick.
Okay, I'm just gonna write them over here.
Well, I just thought it was like, you know, yeah, the AP people are like, have a notepad. But this is way cooler.
No, they do people on our meter. You're like, you don't get
Yeah. Gosh.
Okay, same thing, I just rewrote them. We're gonna rewrite them too, though, to help with our rearranging here.
And then they say this.
Yes.
When, like, on the test, do you have to write out the word rate, or can I just put, like, bar? Like, I'm just lazy, I'm just wondering if I can make shortcuts.
I've only, whenever people write rate laws, and it's interesting, I don't know why, but anytime I've seen rate law, they always write the word rate.
Okay.
Rate equals.
Ooh.
I don't know if it's because they don't want to get it mixed up with, like, you know how we have an R value in, like, pervert?
Oh, that's true.
Nerd.
I don't know that, but that would be my guess.
Yeah.
Because chemists really do abbreviate lots of things, and I think chemists are lazy. And I'll say efficient.
Ah, that's how I should describe myself.
Yeah.
Even though I'm totally
You
not.
manage your time wisely.
Dude, I'm sure you. That's so true, and then,
Yeah.
Okay, here's what's gonna happen, everybody.
Like you said,
that's true.
Once again, here's our problem, okay? This is the overall rate law, but we can't leave the intermediate in it. Now, whenever the first step is the fast one, or the second step is the slow one, there's also something that normally shows, that will always be in the equation that looks different. Did anyone notice something different about this chemical equation?
The arrow goes both ways.
There we go, this little arrow, okay?
you pointed it
I
out.
did, I pointed that out earlier.
I even
So
wrote
did I.
Okay? This is signifying that the reaction of that step is in a state of equilibrium. Next unit, unit 7, is titled equilibrium. So we'll like learn lots about it, but for now, just understand it's the concept of how
Well, I think it.
a reaction can go forward and backwards. And equilibrium signifies it's happening at the same rate. Okay, simple example is a treadmill puts you in a state of equilibrium. Well, you should be in a state of equilibrium with your treadmill.
But you can do big jumps.
Yeah.
And it looks like you're running really fast, or you're just like walking with very large steps.
But either way, for you to not get thrown off your treadmill, you have to move forward at the same rate the treadmill is going
Yo,
backwards.
did you ever do the thing where you turn it up as like fast as it goes and you just grab the handrails and like act like you're running really fast?
I've been thrown off it.
Really?
I stood on the back.
Yo, that's crazy.
Yeah.
So, I think it was last class you said it like requires energy to like, break bonds or to form bonds?
To break bonds.
To break bonds. So like where's that energy coming from to like break apart the NOBR2?
Good question. So in this case, because what's happening here? Oh, the NOBR2 is breaking apart. Well, one of the BRs is coming off, right?
Right.
So energy can come from a variety of sources. It can come from that they have energy already as molecules. That's why like on our graphs, right, like the reactants are already starting at a certain level of energy. So there's a certain amount of potential energy that is stored within. There's the energy of the movement because the molecules are always moving, right? So as they're moving and as they collide, there's a transition of that energy. Obviously you could supply more energy by heating things up, and that's why some reactions won't happen at certain temperatures. I mean, there's other reactions where you can like send electricity through it that provides energy. It can take it from the surrounding of what it's in. Did that answer your question? So, good question. And we'll have the unit, I think it's the unit after equilibrium, is all about energy transfer. And like, more into that breaking bonds, forming bonds type of stuff. So hopefully that will maybe answer it more for you, but, yeah.
Okay, so what happens to like, this, I've seen this on a few of them.
Okay.
Like, what happens to the BR, the bromine?
Yeah.
It's just gone.
My bro is gone. Sad.
What do you mean it's gone?
It's gone.
Like, so the NOBR plus the NO, never mind, I'm dumb, I just looked at that better.
Okay, you
We're
got that.
good, we're good.
Okay.
You
Well,
figured
it's
it out.
possible because we did find those reactions last time that were messed up, so. Okay, so going back to that idea of equilibrium.
Oh, I missed it too.
Okay, the forward reaction, so these two are colliding and making this. At the same time, some of these are breaking back apart, and it's going forward and back. It's kind of like how I showed you, right, with the little theme, right? Of how, because this first step is the fast one, right, it's kind of doing this like back and forth of forming, breaking, okay? The rate of the forward, so I'm going to put a little F right here to signify, this is showing the forward rate of that first reaction. It's equal to the rate of it also going backwards. That's what equilibrium is defined as. So this equals the rate of the reverse,
Oh, it's simple though.
okay?
Raider?
Raider, is that a dragon?
No.
Yeah, it is.
So now, look at the equation number one, step one, going backwards. The rate law for the backwards reaction would be K NOBR 2.
Probably,
Okay?
I like that.
These are equivalent because it's at equilibrium. Which means, because remember, this was my problem. I needed to substitute this away. This equals
Oh, you can do it. Oh.
those two things. So take this
Yo.
and substitute it in here.
Whoa,
Wait, that makes so much sense.
that does.
Oh, good.
When you just
That was like,
Okay.
So rate equals K. And then this is coming into here. Now notice you can combine like terms, right? So we have two NOs.
Oh, square.
So those can be squared.
would you actually consider it squaring, or is it like?
It's second order, but you do mathematically square it.
Oh, so it is squared.
Yeah, you can say squared.
wow.
Okay, questions?
I'm gonna just take a second to copy this down.
My mind is so happy it worked out like that.
Yeah, me too. I thought it was gonna be something big and confusing.
Make everything else.
It can, I'll be, I can't remember. It can seem confusing, but it's really simple actually, so.
I haven't recovered from that gas law thing, like the ideal gas law.
Oh,
Oh,
yeah,
I
dude,
have
that
not
was
recovered.
that one's still stewing.
Yeah, I'm like still like, I have no idea.
It's okay, it'll come.
I just kind of like hope that I know what I'm doing when I write it
We gotta
down.
reopen the chemistry boxes. Okay, try practice problem 5.9 with your table buddy. Ready, set, go.
If you just put NO2 again without squaring it,
It'd still
would
be
they
right. I don't think they'd work, you know? I don't think so. I would always combine it, but if you didn't, I don't think they would, because it's the same thing, so.
I was just wondering if I accidentally.
I think if you, I think you'd still get points for it. I would get points for it. Because it's the same thing like mathematically, right? So.
Hey, it doesn't tell us.
Oh, sorry. What I told you would always be told to you isn't told to you.
Yeah.
Here you go. Fast, slow, fast.
Oh, that makes sense.
We're pretty much used to it because we always go, okay, take everything I just learned, and there are exceptions.
Yeah.
Like it will always be told to you except.
For every question I test.
So there is that one. There'll be a couple.
But only these 16 have.
Pretty much.
So fast, slow, fast, that means it's not
Yeah, get out of here, cross that one out.
It's gone.
Taylor, do you want a note jacket? I have some extras.
I have.
No, I know you have them, but do you want another one today so you don't have to write all the equations down? Does that help?
Taylor, that's what I had to do
So then
too.
Oh,
you can write.
I forgot my binder.
me too. It happens to the best of us.
Okay.
Just because the
Oh, I
equations
see
are
what
kind
you
of
did there.
light teacher right now.
Oh, wow.
Okay, try out 5.9.
Wait, so since the fast was first,
Oh.
and
Wait, okay, so there's this thing.
what matters, doesn't the fast one still
Determine the
have
rate law that was made, or that's consistent with the given method for the reaction to
Well, I know, but you're still just basically writing the slow rate.
It's just because I think, especially when you get down to the molecular level, slow step is the thing that influences. It's kind of like that thing of like, where it says like, if
How do you know it's
it's
fast?
going faster, but really, in terms of like the overall timing, it's that makes it matter.
She put it.
Does that make sense? So there is an influence, but it's like,
But
it's so.
is the back and forth one.
Wow.
Good word choices. But yeah, definitely.
So what's the
Good question.
Is
Set your pencil down when you're done.
This down both sides.
Oh, maybe it's just F. They're just two of them.
Did you do the last one?
I don't think they just don't. Like,
So just
this
this
makes
is
it go faster.
So the rate is right.
That's the same thing. Yeah, so it's just that.
Wait, I'm so lost.
I feel like that shouldn't be right. Is that what you got?
Are we using the?
Yeah, that's like.
So, NO2 F2
This is very positive to hear
and
that.
so on, you know the
I
middle
spent
one
many
is
years
slow.
trying to make this simple.
Yeah. So then.
And so then,
I taught this
you
differently
know
every year,
that
because there's never been
NO2
something that's like,
F2 is equal to
always
that
been like
one.
people.
This is way better than I
So
do.
you know the
Now
overall
we'll see how I improve this.
I'm so scared.
one is rate
Wait, I have an idea. What if there are two?
I don't know if they can have that.
Because look, there are
Say that
two.
again.
There are two.
They're so similar.
So maybe like.
So, well, it's an integral F2, so it is an
Yo, I don't get
Yeah, but
school
this
geometry.
is, that doesn't.
Good observation, because it's like that one subscript difference is like,
And this is pretty much.
You don't have that much time to
Go back to the basis one. It doesn't have a equilibrium. You have to have one.
Oh.
So it goes faster this way, and this is the slowest one.
So would it be then?
oh no, just
So the overall is supposed to be this, but since this is
that'd be another
intermediate,
as well.
and this problem goes into the intermediate, you just write this. So this one's the overall one. Overall.
Yeah, dude, my brother can do this thing with his pen where it just like flies around his thumb, and I don't know how to do that. I'm kind of jealous. Can anybody do that? I don't know how to do it. It's like.
I think you can do it.
You can do it.
Like occasionally.
Oh yeah. How are you doing that?
So it's always about the
Let's
style.
go back.
The reverse rate is just like
Yeah, and this is
Here,
already
this was our
the,
answer.
because this was our intermediate.
You have to start how far back.
We had to find something. Substitute.
these two are the intermediate
So
because
the first step is this equals this. And so it's substitute.
Oh, I did it. That was awesome.
These two
You're the best.
And maybe.
Oh
this
my
is-
Like heavier.
Dude, you're so much cooler than Taylor. Holy crap.
Is that?
Hey, I'm so sorry. I don't know your name.
Yeah, because it's different from everything.
Yeah, okay.
I know, our setup was
I
Gabe,
would-
what's your name?
Kimberly.
Kimberly. Gabe, Kimberly.
I mean, just how you know how you
I'm
can
Gavin.
Yeah.
We got branding and
So I guess if we don't have the first one, then we could.
I saw this video where this guy had a toothpick.
In the step, don't look at the overall.
And then he just flipped it and stuck
Just
it.
look at the step.
But
Yeah,
since
it's like
this
the
one
guy
is
from,
exactly
This is my
that,
favorite.
like Rio or
So
whatever.
I'm just substituting this for something else.
Oh yeah, I remember, yeah.
If this F wasn't
Yeah, because they would be the same. Yeah.
Wait, what?
Okay, I think I checked everybody, but let's walk through it just to make sure our minds are in the right, going the right direction we want them to. Okay, so when I need to write an overall rate law from a mechanism, you still always focus on the slow step. So my slow step says that the rate of the slow step would be K NO2F. Okay?
But that's wrong. Well, or it's not wrong, but it's not like.
It's intermediate.
Yeah, that's the word.
Okay? So we need to replace the intermediate with something that is equivalent to it. Now the intermediate will always appear in the step above because that's the definition of an intermediate.
yes.
So intermediate here is equal to these two things. So I'm just going to substitute in those two things, and that should be your answer. If you have this, have a
They kind of like work like logic.
Oh, gotcha. Okay. Questions so far? Okay, we're gonna take it one step up. Flip your packet to the very back where it's blank, because I want to do another practice problem on this.
Wait, real quick,
Blank on the bottom. Yes, Gavin?
like, if step one made something that wasn't an intermediate also, would you have to plug that in for the step two rate law?
You're setting up the question I'm about to ask you.
Oh, that's so awkward.
No, it's perfect.
You're so smart.
Oh, thank
Okay,
you.
with your table, buddy. Find me the overall rate law. Let's see if I can remember.
Oh, it's just simple.
Are we just going to a blank page?
Yeah, I just, after I made the note packet, I realized I wanted another problem, so find somewhere. There's space on the very back, you could do this one.
Wow,
Okay.
Taylor Swift.
Two tasks I want you to do. Task number one, what is the overall reaction? There you go, Winston. Step number two, what is the rate law for the overall reaction?
What's the slow pass one?
Okay?
What was that?
Slow pass? The slow pass one?
Oh, thank you, Zach.
Yeah, I think it's allowed. Wait, so do you just like gone now?
Okay.
Close it?
See, this is the question I was asking.
So I want you to see if you can answer your question.
Oh, great.
So
How
this
nice
is the
of you.
intermediate. The C is the intermediate.
I'm not sure like they actually talking.
Did you just throw the D in there for fun?
So
No, I don't think so because the rate doesn't.
Let's
have
do-
one of the units.
That's true.
The rate level does A,
K
T,
and rate K and
the second rate.
Is that top one supposed to be back and forth?
Yes, thank you, Zach. Yeah, the fast step before is always
okay,
like.
so then we have C, but we need to change that.
So then,
So wait, but there's not.
Like this.
Wait.
Oh, but then there's the T.
Oh wait, she added double arrows on that one. I was so
Yeah?
confused for a second. Okay.
I don't know.
So C
I feel like it'd be
splits
fun
up
if I
into
didn't
A, B, so then we just rate equals.
But it says plus right there.
Okay, I'm putting this
Okay.
all over.
So basically.
So wait, we're supposed to find the overall rate law?
Say that again.
We're supposed to find the overall rate
Yes,
law?
finding the overall rate law. Yeah, finding the overall equation and the overall rate
I
law.
think AB.
I think it's AB.
Holding my backpack.
That's what I think because look. So the rate of the stolen is C, and you can't have C, and C splits up into AB because stolen.
But then you have a C.
No, I'm like 90% sure.
That's what I would do.
Really?
AB.
But we always cared about Isaac. You never just throw him out, okay? You can't do that. You can't just throw
What if
somebody
you
out.
just
But
had
what
one
is
runner
the-
twice? That would be
That's
more
just what-
useful than Isaac.
I know, but
No offense, Isaac. 'cause-
Isaac is a human being. Look at him.
But that doesn't mean that we
Yeah, a
need to.
person's a person no matter how slow.
Thank you, Morton.
What if they were so slow?
They were like,
You have to realize
They
that the
died
qualities
before they
of
did.
Isaac is
Then
essential
were they ever
all
really a
yes,
person?
happening.
a person.
Okay, I'm gonna give you 1 more minute to see what you can come up with.
And he's important in the music.
Yeah, and these.
Right now. Micah, sing a song.
Like the
I wanna be
overall
serious.
Yeah.
We're doing Suzuki, right?
You guys are?
Yeah, and Micah is just right over there.
The D.
Morning announcement,
Ah,
Micah.
that would be fun.
Yeah.
I just,
Micah is in my first.
Yeah.
That's what I think that's
Except she
the
doesn't understand
overall
he's a
alliteration.
4-year-old like that, right?
and that's what overall
So
rate
it has to be in.
I just heard her mortgage for the first time last night, that's why I was in my head.
Oh, yeah?
Yeah, she kept, like, she kept getting confused. I was like,
Yeah.
My only problem is
No.
Micah doesn't understand alliteration.
If that makes
She
sense.
doesn't?
No.
You're close.
Oh, morning announcement.
He's like, and have yourself a wonderful Tuesday. You're like, what
Fail.
are you doing?
Micah, you failed. I love you, Micah. Because he's my director.
But it's just an
right?
idea.
So I have to be nice.
If,
He's your director and your adjunct.
Well, I'm in a different play and you were
Right.
the director for it.
or would you like to see
I know, right?
people like half
We
of
did,
AB?
it was a lot of fun.
Okay, let's solve and see what we can do.
Wait, no, roll.
So the overall
Oh, wait,
reaction
of course.
should be this. So you can have a smiley face if you got the overall reaction correct.
I just need one more to pull up my bar.
Well, if you get the rate law right, you'll have another.
Oh, go.
Okay, now, what step do we always focus on?
This is the slow.
The slow step, okay? This in a sense is my answer. But what's wrong with it?
There's
It
this.
has an intermediate.
It has an intermediate, right? So we gotta substitute out that intermediate, okay?
Wait,
I didn't write that right.
yeah,
Yeah.
it's like, wasn't that a name?
Yeah, I was concerned like.
Cause I was like, that
It's
name
like,
would be-
Sorry about that, that was weird.
I thought I knew how to do that.
Okay, so we know that the first step, right, is at equilibrium, it's going back and forth. The difference here, where we all kind of got stumped, is that does C equal A and B?
No.
Huh. A and B equals C and D, right?
Okay, I'm putting it over D. That's
It's,
We
you
have
have to write it really
C.
quick then.
over
D.
There we go.
Okay, same thing as before though, we just wanna substitute just C. So using algebra, how would I get C by itself?
Oh my gosh. You divide! Taylor, you're a genius!
Oh dear.
Oh my gosh. Wins, did you win? Did you make it?
What?
Here, let me finish.
I did that.
Winston, you win, you were everywhere by Taylor.
Okay, so we're dividing, look
No.
everybody, by
No.
D,
No.
and then I'm gonna substitute all
Oh,
of
but the
this
E isn't over the D.
in for C.
So we still messed up.
Dang.
So our final answer can look in a variety of ways, because that's how math works.
I guess that kind of makes sense.
Okay, the way I would write
I
it,
think we just kind of forgot about
is I have A,
when we saw that.
B, E is multiplying as well,
Yeah,
over,
yeah, I didn't
Oh,
really
wait.
get that.
E is over D.
oh, I dropped my K. Now, you could also write it as if it, you want to, you could also do A, B, D, That's the same thing mathematically. Yeah, because when you're multiplying and dividing, order of operations doesn't.
Okay, but
Anybody else means that I got it right.
Wait, let's see it.
I did.
You got it right. Yo,
Okay, questions on that?
let's go. That's cool. Can I have a smiley face?
You got that, yes.
You know what, Taylor? You get the smiley face.
I do have a question.
Yeah.
How do you divide by a ton?
I still do not
Okay,
understand.
final thing before we run out of time in our 2 minutes.
Smiley face on it, just.
Let's make sense what this, so we know how to do it mathematically, but like what does that mean in real life, right?
Yeah.
Okay, if this is my rate law, what does it mean to have a chemical on the bottom? First off, what do brackets mean? Concentration or molarity. Okay, what is rate?
Great.
Good, how fast it's going.
Dang, you're popping off.
So what this is telling us is that the rate, how does D influence the rate of the reaction? If I add more D to this reaction, it slows it down.
Wait, so
It's
it's
the
like
anti-catalyst.
opposite?
Kind of. Okay, so in a sense, that's what it's saying is that by adding D, it slows the reaction. It just tells you how it influences it. Yeah, you don't have to add D. The best reason would be not to, right?
Oh.
But if you do add D, it's going to slow it down. So, did that answer your question, Winston?
Okay, understand.
Okay, any last
Stop it.
questions?
I don't want to give this.
No, but look.
Okay.
Okay, homework tonight is a bunch of problems like these.
Oh, cool.
Okay, and then a few pages of reading.
Why do we have two more?
Really? I